In this topic, we'll be looking at heat capacity and specific heat capacity equations. What is heat capacity? Well, let's bring up our equation. Heat capacity is given by the equation heat capacity equals heat energy over temperature rise or temperature change. Okay, so that's very important for us to understand. Let's abbreviate it. Heat capacity is going to be given by the capital C, right, which is equals heat energy. We're going to be using E with H over temperature change to abbreviate our equation, and its unit is going to be, let me write down, unit is going to be joules per kilogram with a -1, or you may write joules per kilogram with a slash. Okay, it's the same thing. So rearranging this equation, we get that cross multiply, we end up with heat energy is equals to the heat capacity times the change in temperature. So that's the heat energy, right? So what does this mean? This is the amount of heat energy needed for a body to increase by 1 degree Celsius or 1 Kelvin. All right, let's go to specific heat capacity. So this was heat capacity. We go to specific heat capacity now. So specific heat capacity is equals to heat energy over mass times temperature rise. Very important. Note the difference between this equation and this equation. This is talking about a mass, so this is being specific, right? And the mass, we usually use it in kilograms. Abbreviating it, specific heat capacity is going to be given by the small c, which is equals heat energy, straight E with the H, mass M, delta T for temperature change, and this is going to be given by the unit joules per kilogram per Kelvin, or joules per kilogram Kelvin. Alright, so we put simply joule slash kg k, or simply C. Alright, rearranging the equation again, we end up with energy is equals mass, specific capacity, change in temperature. So we end up with that equation. The relationship here, and the reason why we rearrange it, because we want to find if there is something common with them. So the relationship between heat capacity and specific heat capacity is that both of them give us energy as the units, all right, which is measured in joules. So what we do is that we arrange them. So this is now where algebra comes in handy. So we end up with E H equals capital C, the change in T, equals M C, change in T. Alright, so forget about this heat energy now. Notice that both of them have change in temperature. So we can get rid of change in temperature, and we can say that C is equals mass times specific heat capacity. So the heat capacity is equals to the mass times the specific heat capacity of an object. So the heat capacity now, right, which is this, depends on both its mass and the material it is made up of. So this is for us to understand why is it. So let's write that key point there. Heat capacity of an object or material depends on both its mass and the material it is made of. So that is what we mean by heat capacity and specific heat capacity. Let's try a few examples now. Another equation that you need to remember for this topic is power equals, okay, so power equation is very, very important in this topic. So our power will then equal, so power equals energy divided by time. Okay, so we need to remember this equation, very, very important in this topic. So let's consider a scenario for our first example. Let me put this equation here to one side and bring our first example. So a hot water tank or a container, you have this container here, okay, and this container contains 180 kilograms of cold water, and let's say the temperature of this cold water is 10 degrees Celsius. Calculate the quantity of heat energy required to raise the temperature of the water to say 80 degrees Celsius. So I want to know how much energy do we need to apply here for this to now be 80 degrees Celsius, still at 180 kilograms. All right, so we will be applying heat to this, or how much energy will be observed by this water for it to become 80 degrees Celsius. Since we are talking of a specific mass, not just a body of water or of a material, we need to use specific heat capacity, all right, in our equation. So the equation that you are going to use is as follows. You will be using, where's the equation? You will be using this equation because we want to know the amount of heat energy. We have the mass, we have the change in temperature that it should go through, and we have the specific heat capacity of water. The specific capacity of water, of pure water, is standardized. So for this topic, we will be given to you, or you may need to solve for it. Okay, so let's go and solve this problem. So in this case, the specific heat capacity of water is going to be 4,200 joules per kilogram per Kelvin. Okay, all right, so we have that. Do we know the mass? The mass is 180 kilograms. Do we know what's the change in temperature? Well, we don't know what will be the change in temperature, but we do know that it is at 10 and we are expecting it to be at 80. We want to know how much energy it will take for it to go from 10 to 80. So we do know a change in temperature. So a change in temperature is given by 80 take away 10 degrees Celsius, which is equals to 70 degrees Celsius. 1 Kelvin is equal to 1 Celsius. So this is also equal to 70 Kelvin. All right, so let me write a note here. 1 degree Celsius is equals to 1 Kelvin. I am not saying that 1 Kelvin is on the Celsius scale as 1 Kelvin. I'm saying that 1 increase in Celsius is 1 increase in Kelvin. Okay, so now the energy required. We know that the energy is equals mass, specific heat capacity, change in temperature, which is then 180 kilograms times the specific heat capacity, 4,200 joules per kilogram per Kelvin, times the change in temperature, which is 70 Kelvin. Okay, so we use that to solve our problem. Are there any units that will cancel? Yes. Kelvin with Kelvin, kilogram with kilogram. So those units will cancel. We'll obviously end up with joules. So let me write the units joules. So we establish that. We take our good calculator and we start to multiply. So we say 180 times 4200 times 70, and that is going to give us 52920 and 3 zeros. But because we are doing it subject where we can use scientific notation, we can put this to be 5.292 times 10 to the 1, 2, 3, 4, 5, 6, 7 to the 7th power joules. Okay, so we can use that. So that is the amount of heat energy it will require for this container or this body of water, which is 180 kilograms, to change from 10 to 80 degrees Celsius. This is the amount of energy it will be required for it to observe.